taking a reading with the sun, I mean, noticing those celestial cycles in the first place. I mean, it's all about how things are organized in our brain, and this isn't something we really understand very well. Neuroscience is a very young science, and I guess the other side of that, I mean, if it isn't, yeah, what if it is an illusion? If it is an illusion, like, you know, the spinning chair illusion, where you think the universe is whirling around you, I suppose the answer to that then would come out of neuroscience. So, I mean, I guess the answer is maybe.
You know, what you refer to as psychological time, you know, what are the boundaries of what, you know, would be merely psychological time and what would be, let's say, objective time? And I know that objective time is postulated mathematically, but then how much is even our very mathematics implicated in our, you know, more than our psychology, and, you know, as a conscious experience, but, you know, in a Kantian sense, you know, the very filters through which we see, perceive, and even can conceive.
Yeah, there's probably not much more I can say. I mean, this ties in so many different things, you know, psychology, philosophy, you know, the mental world as it relates to the world outside, and different people have speculated about those connections. Roger Penrose is one of them.
Yeah.
I think, so thanks very much. We'll probably have to go to the next question. Thanks.
Something I was thinking about at several points in your talk was the principle often articulated that causality is time-directed. Past causes can have future effects, but not vice versa. Do you know when that principle was first articulated, and do theoretical physicists today take it seriously?
Well, okay, so the question gets to the root of, I guess, cause and effect. And I'm not sure, I probably didn't explain or go over that very clearly maybe in my talk. I talked about how in Einstein's world, you don't have this unambiguous ordering of things. However, you still can't have effects coming before their causes, not even in Einstein's world. So causality is still preserved, as far as we know. And I guess you were asking, like, how far back does that idea go? I don't know. I mean, it probably goes back to Greek philosophy and, you know, maybe earlier, right?
Well, the Greeks had different sorts of causes that worked in both directions.
Oh, well, they have different ways of understanding causes. That's right, of course. I mean, there were like 4 different causes for a thing and all that. I don't know. In physics, yeah, causality is important in physics in that you don't want to accidentally come up with a theory that contradicts it, right? It seems to be very fundamental, and I guess I'll have to leave it at that.
There's a story by Max Beerbohm, you may be familiar with, written probably around the same time, somewhere around the same time as Wells' Time Machine. Very entertaining story called Enoch Soames. You ever heard of that one?
I'm not familiar with it.
Enoch Soames was a character in this Beerbohm short story who makes a pact with the devil to go 100 years into the future in order to see what into the British Museum Library in order to see what was thought of him. And when he shows up, he finds that he is described in the library as a character in a Beerbohm short story, fictional character.
Okay, that's pretty good. I should pick that one up. Thanks. It's funny. I mean, on the side. I mean, if there are any more questions, that's terrific. If there aren't, I'll just go off on a tangent very briefly. But it's funny that, I mean, time travel is such a bountiful subject that, I mean, even in the next 2 weeks, we've got 2 different movies, Hollywood movies opening that sort of play off on that. Well, one of them is based on a F. Scott Fitzgerald's short story where the main character gets younger and younger as time goes by. Interesting stuff. Yeah, The Curious Case of Benjamin Button. And the other one is, well, it's also based on a novel from a couple of years ago. The novel was called The Time Traveler's Wife by Audrey Niffenegger. And I read that one. It's very interesting. But of course, so the main character sort of jumps. It's not a journey. He jumps back and forth through what I would call Newton's absolute time, encountering the woman who either is his wife or, when she's much younger, when she's a little girl, the woman who will eventually be his wife. But it's all I mean, it's very well written until you stop to think about it, because once you stop to think about it, it's all crazy. And it's explained in the book as a genetic disorder, but I don't know how genetic disorders make you travel through time. They do it with some, near the end of the book, I'm not going to give away the ending, but the guy who sort of figures this out has mice in a laboratory and, you know, puts the mutation into the mice, and yet they travel through time as well. But they just go to, like, the cage where they grew up in. So I don't know why the hero goes to, like, the garden where his future wife lived in as a child. I mean, it's all a bit crazy, but I'm totally looking forward to the film. Were there any? Oh yeah, go ahead.
Okay, I was just curious. In your talks with a lot of these people that you did through your research, did anybody propose any experiments that you haven't talked about here to try to determine what time is, or to try to get at this idea that you go, well, that's interesting.
Well, I guess the experiment, probably just the ones that you're already familiar with. I mean, things like the high-energy particle physics experiments that are going to be going on at the Large Hadron Collider. How directly they'll illuminate the nature of time, I don't know. I mean, if you probably keep up with these things, they're looking for the Higgs boson, and there's other things about fundamental physics that they hope to address. So, you know, there's a maybe there. And cosmology, I didn't go into detail, but you know, the cosmic microwave background radiation, this is this echo of the Big Bang, this microwave radiation that is visible in every, or detectable in every part of the sky. And maybe if that's probed in more detail, it will give some hints as to whether, you know, Andre Lin's picture of eternal inflation is right, or Steinhardt and Turek's picture of the brain worlds crashing back and forth. I mean, maybe, right? Yeah. Or gravitational waves, that's another under development, but looking for gravitational radiation maybe given off at the time of the Big Bang. So these are some things that maybe might.
Okay, because I was thinking of the thought experiment in reverse, where you do something to create the thought experiment, as opposed to take a thought experiment and then say, oh, okay, how do we devise an experiment to test the validity of this?
Yeah. I don't know, a lot of things in science do happen sort of by accident. I mean, someone might accidentally do something that gives a bizarre result. And I mean, there were bizarre results from 100 years ago that sort of eventually led both to Einstein's breakthrough and also to the quantum breakthrough, you know, in addition to the thought experiments, right? So there were unexplained things in the laboratory. We shall see. Yeah.
We're almost at the level of Ptolemy's universe, where we have this physical perception, and we haven't been able to break out of it yet, even so we have
perhaps,
a lot of more interesting data than what they did at the
so who knows? Maybe we're due for a revolution like the Copernican revolution, or in fact, maybe everything we've figured out. You know, maybe we're already on the right track, and we just have to get used to these odd results.
Okay, thank you.
Thanks. I guess we should probably make this the last question, do you think? Yeah, so after this, I'll set up the books for sale at the back and so on. So, yeah.
Yeah, when you talk about time traveling, is there any difference between matter and energy? Because I remember some time ago I heard of a guy working on physics for a machine which was capable, actually that was the idea, to feed the machine in the future with some photons or something, and listen actually to the output.